Okay, today we're going to continue on with talking about delta H. And in this one, we're talking about the delta heat of reaction, so the enthalpy of reaction. So there's two different equations we're going to be looking at. First of all is if we are given the total heat of reaction of the substance. So if I look at here, we've had equations like this before where we've taken products minus reactants. Here we're going to use the same equation, but we're using the heat of reactions. So when I look at this equation here, I have C3H4 plus 4O2 forms 3CO2 and 2H2O. What I need to do first of all is I need to find out what is the sum of the delta H's of each of them in kilojoules per mole. So when we look at this here, if I look at my reactant side, I have C3H4. And I have how many of them? I only have one of them. So I'm going to take 1 times my 184.9. So 1 times my 184.9. And I have 4 oxygens. Now, if I look at that equation, because there's no oxygens in that box. Because if I read that statement, it says the enthalpy of formation for an element in its elemental state will always be 0 because it takes no energy to form a naturally occurring compound. Therefore, O2 is 0. So it's 0 kilojoules. So my reactants equals 184.9. My product side, I have how many carbon dioxides? I have 3 of them. So I'm going to take 3 times. And what is carbon dioxide? We have to make sure we look at the elemental or the states of matter too. So sometimes you'll be given the gas, liquid, solids, and you got to make sure you choose the correct one. And so the gas here for CO2 is negative 393.5. And we need to add how many waters? And we have liquid there. We have liquid water. So H2O, we have 2 of them. 2. And that's negative 285.5 or 0.8. When I add those together, you do your math and you add them together, you would get a negative 1752.10. And that is in kilojoules per mole, kilojoule times mole. Everybody with me on that? Now to solve for my equation, we're going to take products minus reactants. So I'm going to take my negative 1752.10. And I am going to subtract my reactants, which was 184.9. When I get a total of that, I would get a negative 1937. And that's my heat of reaction, and that's kilojoules. I look at up here, the units on the top there says kilojoules. And remember, it's mole minus 1, so that means it's over. So it's kilojoules per mole. So kilojoules per mole. Is that an exothermic or an endothermic reaction? I have a negative number there. So it is an exothermic reaction because it is negative. Exothermic because the delta H is negative. Let's look at the next one. Now, so this is the typical one. If you're given the delta H of, if you're given something on here and you're given the substance. Now we're going to go on to another way, and we're going to be breaking apart each substance into the bonds. And here you may have to draw out your bonds, but I've already have them all drawn out for you here. So if I'm looking at the delta H here, the delta H of this equation here is bonds broken minus bonds formed. So in an equation, where are my bonds being broken? Are they being broken in the reactants, or are they being broken in the products? They're broken in the reactants. So, and then where are bonds being formed? They're being formed in the products. So do not go products minus reactants in all of them. Think of this as, if I'm looking at average bond enthalpies, we're taking bonds broken minus bonds formed. So they're broken on the reactant side, they're formed on the product side. So bonds broken is the reactants, bonds formed is the products. So let's look at a problem here. So I have CH4 plus 2O2 forming CO2 plus 2H2O. Now, if I look at CH4, I have my carbon in the center. Carbon has 4 valence electrons, and so it can form with 4. So I have CH4, I have 4 of them. Oxygen is a diatomic, and since it's got a minus 2 charge, it has got a double bond on here. If I look at the carbon dioxide here, carbon dioxide means I have 2 oxygens. Carbon has 4, oxygen has 6, so it can form 2 bonds on both sides. So therefore I have carbon dioxide. Now if you could put the lone pairs on here, and you would be okay on that also. They'd probably want you to put the lone pairs on it. And then I have water, H2O, and if I had my 2 sets of lone pairs up on top. So now what we got to do is we have to analyze the entire equation, because if I look at this chart here, we're looking at the bond enthalpies of each individual bond. So you'll be given a chart like this, and you need to figure out what the bond enthalpies are. I'm going to make this a little smaller here, so that way I can see the chart also on here. And you can see the chart. So if I look on this first side, on my reactants, I have CH4. And my first one, I have CH bonds. So I have a C to an H. And how many C to the H bonds do I have in that methane molecule? I have 4 of them. I have 1 CH here, 1 CH here, 1 CH here, 1 CH here. So I have 4 of them. Now I have to look up at the chart, and I have to look at for CH. I look up at the chart, CH is 413. 4 times 413. Okay. What else do I have there? I have an O double bond to an O. And how many do I have of them? I have 2 molecules. So I have an O double bond to an O, and I have 2 of them. Now, if I look up here and I look at for O double bond O, it is 495. Liking me here, guys. Now, if I multiply these out, This here, 4 times 413 gives you 1652. 2 times 495 gives you 990. If I add those two up, I get a total of 2642. On the product side, what do I have on the product side? I have a C double bond to an oxygen. C double bond to an oxygen. And how many bonds do you see there? I see two of them. I look up at the chart and I look for C double bond oxygen. C double bond oxygen, I have 799. What else do I better put that correct there. Oxygen. What else do you see there? I have in that water, that takes care of that CO2. But now I gotta go to that water molecule. I have OHs. In one molecule, I have two OH bonds, but I have two molecules of water. So therefore, I have a total of 4 OH bonds. Now, if I look up at the OH, OH is 463. Do some math here. 2 times 799 gives me 1598. This gives me 926. When I add them together, I get 2524. Now, remember here, if I'm taking bonds broken, on the reactant side is where they are broken. On the product side is where they're being formed. So I'm taking 2642 minus the 2524. And I would get a 118. Okay, if I look at my unit up on here, it's kilojoules per mole, 118 kilojoules per mole. Endothermic or exothermic? It is an endothermic reaction because the delta H is negative, is positive. Let's look at another problem here. So now I have two C2H6s bonded with 7 oxygens. I have to have a balanced equation. If you don't have a balanced equation, you're not going to be able to get the right answer. And it forms 4 CO2 plus 6 H2Os. So you may be given this equation and you need to draw these structures. Because in order to draw these structures out, you're going to have to be able to, that's how you're going to be able to see the bonds. But on the AP exam this year, they said you would not have to do any drawings. So because this would be too hard to draw. So they would probably give you this for you to solve for it. So let's break it all apart. On the product side, on the reactant side, I have C-H bonds. How many CH bonds do I have there? I have 1, 2, 3, 4, 5, 6. How many molecules do I have of that? I have 2. So I have to take 2 times 6 gives you 12. Everybody see that? 1, 2, 3, 4, 5, 6 times 2 gives me 12. 12 CH bonds. Now I have to look up at CH. CH is 413. What else do I have on the left-hand side of the equation? I have O double bonded to an O. So I have oxygen double bonded. How many do I have there? I have 1 right here, correct? But how many molecules do I have? I have 7. So therefore I have 7 And now I have to look up there to see what is oxygen double bond. It is 495. Do my math on this side. 12 times 413 gives me 4956. And I do my math on here, 696 gives me a total of 3465. On my product side, what do I have on my product side? I have a C double bonded to an oxygen here. So I have a C double bond to an oxygen. How many bonds do I have here? I have 2 in carbon dioxide. But how many molecules do I have? I have 4. So 2 times 4 gives me 8 total. Right? Do you see this? 1, 2 times 4 gives me 8. I look up at the chart. C double bond oxygen. C double bond oxygen gives me 799. What else do I have on the right hand side, on my product side? I also have water being produced. And so in water, I have an OH bond. How many OH bonds do I have there? I have 2 in one water molecule, but I have a total of 6 total water molecules altogether because I have a 6 right here. So I have 6 times 2 gives me a total of 12 bonds, 12 OH bonds. But I have to look up at OH. OH is 463. Do my math here. 8 times 799 is 6392. OH, 12 times 463 gives me 5556. I add those two together. I get 11948. Now, which side is my bonds broken? Left-hand side. These are my bonds broken. Bonds broken minus my bonds formed. So 3465 minus 11,948 gives me a negative 2831, and that's kilojoules per mole. Exothermic or endothermic? It is an exothermic because it is negative, because of a negative H. That is my justification statement. Okay. You need to have an answer, and most times they'll want you to have a justification. But sometimes your math can be your justification. But if they want a written statement, it's negative because it is exothermic because of a negative delta H. Let's look at another one here. Okay, so I have C2H4 reacting with HBr, forming C2H5Br. So you're going to have to draw it out. Now, if I look at that, I only have C, you have my double bond here, and I have HBr, and I have C2H5. You always put your carbons in the center. Carbons usually are, if you're looking at, when you guys get into organic, you'll always put the C's in the center, and you'll connect them together because it'll tell you how many carbons you should have in your chain. So you have 2 carbons in your chain, and then you got to put your hydrogens around, and you have 4 of them. So therefore, carbon has got 4. So 1, 2, 3. That means you have to have a double bond there. HBr has got 1 valence electron, 7 valence electrons. So we have HBr. And then we have C2H5. I put my 2 C's in the center. Then I pop my H's around. How many H's do I have? I need to pop 5 of them around. 1, 2, 3, 4, 5. I have 1 extra spot there, and on that extra spot, I'm going to pop my bromine that's got 7 valence electrons. So therefore, everybody is happy. So now let's look at what do I have here. I'm going to make this a little smaller here so we can work in this box here. So on my reactant side, what do you see there? First of all here, I see some CH bonds. How many CH bonds do you see there? I see 1, 2, 3, 4. Look up on top, find my CH. CH is 413. What else do you see on the left-hand side? Oh, and in here I also have a C to a double bond to a C. So I have a C double bonded to another C. You need to make sure you put those C's in there, because if you don't put those C's in there, you're not going to get the right delta, the right kilojoules there per mole. And how many C double bonds here do you have of C's? I have 1. And what is a C double bonded to a C? C double bond to a C. It is right here, 614. Do I have anything else on the left-hand side? Oh, I got to put that HBr over there. So if I have an HBr, I have 1 going to an Br. And I only have 1 of them there because in my balanced equation, I only have 1 HBr. And how many HBRs is, what is the HBr? If I look at HBr is 366. Let's do our math on this side. 4 times 413. Did I do something? Is 1652. And I have a C double bond C, and that's just times 1. That's 614. And I have a 366. If I add all 3 of those up, I get a value of 2632. On the product side, what do I see here on the product side? I have some CH bonds. I see them. How many CH bonds do you see there? I have a CH here, CH here, CH here, CH here, CH here. So I have 1, 2, 3, 4, 5 CH bonds. And what is CH? Oh, went too far. CH is 413. And what else do you see in that one? I see a carbon to a carbon, right? It's a double. It's just a single bond there, not a double bond. I have a C to a C. And how many C to a C's do I have? I have only 1 of them. And a C to a C. If I look at here, 348. And what else do you see in that molecule? Oh, there's a C to a Br. Better take that one into account too. A C to a Br. And how many do you see of that? 1 also, right? So let's look at CBr. CBr is 276. It's right here. Let's do our math. 5 times 4, 413. Oh, did I do them? Five times 413 gives me 2065. And I have a C to a C. And that gives me 348. And I have a C to a BR, 276. When I total those all up, I get a value of 2689. Now, once again, it's bonds broken. Bonds broken is on the product or the reactant side. These are breaking apart to form these. So once again, these are being broken to form these. So you have to take bonds broken minus bonds formed. So 2632 minus 2689. And that should give you then a negative 57 kilojoules per mole. It is a negative, therefore it is an exothermic reaction because the delta H is negative. Now on your assignment, oh, I have one more here. I forgot to do a chart here. Let me pop a chart in here. Okay, let's look at this one here. I have N2 plus 3F2 forming 2 NF3s. First of all, on the reactant side, I have an N triple bonded to an N. So I can't make a triple bond on here, so I'm just going to go N to an N. I'm going to put triple just because I can't put triple bond on. So an N triple bond N. How many do you see there? I only have one of them. I need to look up here. I need to find an N triple bonded to an N. I see N, there's a single, double bond. You know what? Guess what? I don't have that on here. I guess we're going to have to look it up. N, triple bond, N, and bond energy. What is the bond energy of N2? N triple bond, it is 945 kilojoules per mole. And we have 1 times 945. What else do you see there? I have an F to an F. Right, they're only single bonds because fluorine has only got 7 valence electrons, so it only needs 1. And how many do you have there? In my balanced equation, I have 3 F2s. So that means I have 3 bonds. And do I, in this chart, do I have Fs? Oh, I do have an F. 155. Okay, let's add these up, multiply them. So this is 945. 3 times 155. 3 times 155 gives me 465. Whoops, I should put this. Like I was doing the other ones, huh? $945 plus $465 gives me $1410. On the right-hand side of my equation, on the product side, what do I have being formed over there? I have nitrogen trifluoride. And what do I have here? I have 1, 2, 3 NF bonds. And how many is being formed there? 2 of them. So I have to take 3 times 2. So that actually gives me 6 NF bonds, right? 1, 2, 3 times 2 gives me 6. Do I have NF up here? I do. NF is 272. Have anything else on that right-hand side? Nope, that's all I have. So I take 6 times 272. 6 times 272 gives me 1632. Now, because I take bonds broken minus bonds formed, so 1410 minus 1632. 1410 minus 1632 gives me a negative 222 kilojoules per mole. Therefore, it is an exothermic reaction because the delta H is negative. Remember that a delta H, when it is negative, it is giving off heat. If it is giving off heat, what is it? Is it absorbing or releasing? It is releasing, right? So it's giving off heat. So if it's an endothermic reaction, it is absorbing heat because it's taking it in. So that is it for today. Good luck. You will have to draw your bonds. So make sure you draw your total Lewis structures before you start calculating out your bonds, your bond energies. Good luck. Talk to you later. Bye.